So guys, we were talking about this classical approach or axiomatic approach to probability. What did we discuss in the last lecture? Something very important, that if you have a random experiment, so random experiment is there with you. When you perform it, you are actually getting n equally likely, so word is very important, n equally likely possible outcomes. Right. Now these possible outcomes are also called elementary events. So by performing the random experiment, you are basically obtaining n equally likely elementary events, right? There are n possible outcomes which can occur as a result of performing this random experiment, and each one of them has equal chances of occurrence. No favoritism is given to any particular possible outcome among these n. Now, once you have this n equally likely possible outcomes coming, what did we discuss next? That probability of each elementary event will be 1 by n, and obviously it is going to lie between 0 and 1, right? Probability of each elementary event, because P is a probability function, so it has to satisfy the axioms. That is what is the meaning of axiomatic approach to probability. So P is the probability function corresponding to this random experiment, then clearly probability of each elementary event will be lying between 0 and 1, but because the elementary events are associated to a random experiment which has equally likely possible outcomes, that means each elementary event has equal chances of occurrence, that is why the exact probability comes out to be 1 by n, which also lies between 0 and 1 obviously. Moreover, we also discussed that if I just not talk about elementary events associated to a random experiment, but talk about any random event as well. See, if there are n possible outcomes associated with this random experiment, there are 2 to the power n subsets of the sample space. That means 2 to the power n events in all. Out of that, only n are elementary events. So these n elementary events have probability of occurrence as 1 by n. Left out 2 to the power n minus n events also have what probability? Probability of any event is m upon n. That is, number of outcomes or possible outcomes favorable to event A, or whatever event is, whole upon total number of possible outcomes which are equally likely to occur, and that word has already been mentioned. Clear? So this is the probability of any event, and we also discussed that it is also between 0 and 1. So not just probability of elementary event is lying between 0 and 1, but probability of any event also lies between 0 and 1, where if probability of an event is 0, it is greater than or equal to 0, suppose it turns out to be 0, this can only happen if the event is actually the impossible event. Okay? And if probability of some event turns out to be 1, see, the probability can be less than equal to 1. If it turns out exactly to be equal to 1, this can only happen if the event is the sure event, that is sample space. So probability of any event associated to a random experiment which is landing to equally likely n outcomes can lie between 0 and 1, and that probability will be equal to 0 when the event is impossible, probability will be equal to 1 when the event is equal to the sample space or the sure event. Keeping these concepts in mind, we had also tackled some questions, certain examples which used this classical definition of probability to find out the chances of occurrence of a certain type of an event. I told you that there are certain other types of questions which are also posed under the section of classical probability or this axiomatic approach to probability. Let's try to see some of those questions. Now, before I move on to what the question is, let me talk about this concept over which the question basically will be asked. We are going to talk about well shuffled deck of 52 cards. These are your well shuffled deck of 52 playing cards. So, let's try to understand what is their structure. You all have seen this deck of playing cards, right? Each card is unique in its own way. Each card is different from the rest of the cards in its own way. So, what is the structure which basically this particular deck of cards follow? As you can see, they are 52 in number. Now, how does this 52 number is distributed among these different cards which make up these 52 cards? So, basically first of all you have to understand that there are 4 suits, suit 1, suit 2, suit 3 and suit 4. So, there are 4 suits in this deck of cards. I can say first is the hearts, then you have the diamonds, then you have the clubs, and then you have the spades. These are your 4 suits. As you know, hearts, they are red in color, right? These hearts are red in color. Diamonds are also red in color. Diamonds are also red. Then you have clubs. These are your clubs which are black in color. And then you have your spades which are also black in color, right? These are your 4 suits. You know this, you have seen the deck of cards. That means you can see that there are only red cards and black cards in the suit. There is no other color there in the suit or in the deck of cards. Now, each one of them is equally distributed in this deck. That means there are 13 hearts, 13 diamonds, 13 clubs and 13 spades. Now, if this is the scenario, you can see there are 26 red cards and there are 26 black cards. There are 26 red cards and 26 black cards. So, this structure is basically trying to tell you something. What is it trying to tell you? That in the deck of 52 playing cards, there are 4 suits, hearts, clubs, diamonds and spades, among which hearts and diamonds are red, clubs and spades are black in color, and hearts are 13 in number, diamonds are 13 in number, clubs 13 and spades 13, which makes the number 26 of each of the red and the black cards in the deck. Now, how are these 13 cards, these 13, these 13 and these 13? Basically what you have is, you have this ace, 2, 3, 4, 5 and so on up till 10. Ace of hearts you have, ace of diamonds you have, ace of clubs you have and ace of spades you have. and each number is like that. So ace, 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 ace of every suit, 2 of every suit, 3 of every suit, 4 of every suit, 5 of every suit, and so on like this, 10 of every suit, right? These are your 10 cards. We call these as numerals. So there is 3 of spades, 3 of hearts, 3 of diamonds, 3 of clubs, and similarly every other number from A to 10. And the left out 3 cards are J, Q, and K. So there is Jack of hearts, you call this Jack. There is Jack of hearts, there is Jack of diamonds, there is Jack of clubs, and there is Jack of spades. So Jack, then there is Queen of hearts, diamonds, clubs, and spades, and there is King of hearts, diamond, clubs, and spades. What are these cards called? These cards are basically called face cards. And so, one thing is sure that you can see 4, 4, 4, there are 12 face cards in the deck. 4, 4, 4. Why? Because there are 4 suits and there are 3 face cards in each suit. So 3, 3, 3, 3, that makes it 3 into 4, that is 12. So there are 12 face cards in the deck of 52 cards, and there are these 10 numerals that are present. One is the ace. So this is the distribution, or this is the making of these 52 playing cards. Understand very carefully this word always you will be seeing. What is the meaning of well shuffled? Whenever you say, or whenever I say, the next question we are going to talk about is the same. Whenever I say that from a deck of well shuffled playing cards, which are 52 in number, I am drawing 1 card or drawing 2 cards, whatever. Then if I am drawing 1 card, when I am saying well shuffled, there are 52 cards, each card can be drawn. So there are 52 possibilities for me for a card to be drawn. That means there are 52 possible outcomes associated with the random experiment of drawing 1 card from this well shuffled deck of 52 cards. If there are 52 possible outcomes and the deck is well shuffled, that automatically means that each outcome has equal chances of occurrence. That means these 52 possible outcomes are equally likely to occur. That is why this well shuffled word is used, so that you can apply the concept of axiomatic approach, or after that what we did, that is the classical probability. Fine, because what I started my class with, which was this, it was only valid for equally likely outcomes, and we are talking about the same approach of probability. Clear? So therefore over here, understand this well shuffled is only trying to tell you that each outcome is equally likely. Okay? Now using this concept of cards, let's talk about a very nice question. The question says, from a well shuffled deck of 52 playing cards, 4 cards are drawn at random. 4 cards are drawn at random. Then what is the probability that all 4 cards are red? What is the probability of event A happening that all cards are red? Now, because I have already said well shuffled, that means there are equally likely outcomes. I know that this is an event and the probability of occurrence of this event is m by n, where m is the number of elementary events or possible outcomes favorable to this particular event, and n is what? The total number of elementary events, total number of possible outcomes. So, first let us find out the total number of possible outcomes. See, 4 cards have been drawn from 52 cards. I am saying that 4 cards out of 52 cards can be drawn in 52C4 ways. 4 cards out of 52 cards can be drawn in 52C4 ways. That means the possible number of ways, all the possible number of outcomes, so basically I should say all the possible ways in which 4 cards can be drawn from a well shuffled deck of 52 cards is 52C4. So, therefore, total number of elementary events or possible outcomes, total number of elementary events is 52C4. So, I have got my n. What about m? M is the number of elementary events favorable to my event A. Now, see, if you can recall this concept, there are 26 red cards. Out of 26 red cards, I want 4 red cards to be drawn, isn't it? That is my favorable outcome. Fine, favorable to event A. That means number of ways in which 4 red cards can be drawn is, now 4 red cards can be drawn. There are 26 total number of red cards in 26C4 ways. This is the number of favorable events to A. Number of favorable elementary events to A is 26C4. This is my M, and therefore probability of occurrence of event A is m upon n, which is 26C4 upon 52C4. Clear? And this is the probability of the occurrence of event A, that is of all the cards which are drawn from the deck of 52 cards. There are 4 cards drawn, are all red. Clear? After this, let us talk about another very case. Next, give me the probability that all cards are face cards. That all cards are face cards. Give me the probability that all cards are face cards. Now, you know probability of B is number of elementary events favorable to this event B. Now see, all are face cards. How many total number of ways are there in which 4 cards can be drawn from 52 cards? They are 52C4. And what all ways are favorable to my event B? Well, all cards are face cards. Face cards are how many? There are 12 face cards in the deck of 52 cards. Out of these 12, I want 4 face cards to be drawn. Any 4. I am not interested in the permutations, I am interested in the combinations. So, out of 12, 4 cards can be chosen in 12C4 ways, right? Because there are 12 face cards. Since we have 12 face cards, out of them 4 face cards can be chosen in 12C4 ways, and therefore this is the probability of event B occurring. Then I am saying that what is the probability of event C occurring, where what is event C? Event C is all cards are of the same suit. All 4 cards should be of the same suit. Either all 4 should be of hearts, all 4 should be of spades, all 4 should be of clubs, or all 4 should be of diamonds. The first question says that 3 numbers are chosen from 1 to 30 and the probability that they are not consecutive is what? So from 1 to 30, in how many ways can you choose 3 numbers? 3 numbers can be chosen out of 1 to 30 in 30C3 ways. This is the total number of elementary events. This is the total number of elementary events. Out of available 30 numbers, 3 numbers can be chosen in 30C3 ways, right? What is the probability that they are not consecutive? So how can you basically start approaching it is, from 1 to 30, you are choosing 3 numbers. In how many ways can they come out to be consecutive? You can have 1, second as 2, third as 3. This pairing you can have, or 2, 3, 4 consecutive, 3, 4, 5, and in the end you can have 28, 29, 30. These are all the possibilities in which 3 numbers chosen can be consecutive. Nothing more than that. It can start with 1 or 2, 3 and so on till 28. So basically there are 28 favorable ways out of 30C3 total ways. 28 favorable ways for numbers, the 3 chosen numbers, to come out to be consecutive. So if I say what is the probability of 3 numbers chosen being consecutive, very clearly it is 28 by 30C3, which is 1 by 145. But the question is to find the probability that they are not consecutive. So the probability of happening of an event is this. So the probability of not happening that event, probability of not happening of that event, that means probability of 3 numbers chosen being not consecutive, will be 1 minus probability of happening of that event, which is this. And this gives you 144 by 145 as your actual answer. So your answer is 144 by 145. So first of all, I found out the probability that the 3 numbers chosen are consecutive, but I wanted the probability of them being not consecutive. So from 1 I subtracted the happening of that event of coming out of consecutive 3 numbers, and then I got the probability of 3 numbers which are not consecutive. Just by using the logic that probability of happening of an event plus probability of not happening of the same event is equal to 1. Moving to the next question, we have again 3 numbers are selected at random from this set which is having 10 numbers in all from 1 to 10. The probability that the product of the 2 numbers is equal to the third. Now over here it's not talking about arrangement, it's just talking about selections. So from 1 to 10 you can choose again 3 numbers in 10C3 ways. This is the total number of elementary events. What are the favorable ones? Favorable ones are those 3 numbers such that the sum of the product of any 2 is equal to the third. Okay, so just think about all the ways in which product of 2 can be equal to the third. You need to choose such 3 numbers. So you can choose a 2, 3, 6. In this case, product of 2 is equal to the third. Either 3 into 2 is 6, you can say, 2 into 3 is 6, you can say. Now you cannot take 3, 2, 6 as another combination because I am not interested in arrangement, I am just interested in selection. Then after that you can say 2, 4, 8. Again, don't consider 4, 2, 8 as another type of a selection. No, that's not another favorable way. After this you have what? 2, 5, 10. So there are just 3 ways in which 3 numbers can be chosen out of the available numbers from 1 to 10 such that the product of 2 is equal to the third, and therefore I am having 3 favorable ways. And so the probability is 3 by 10C3, which is 1 by 40, and that is your answer. Easy enough? Next question says a 2 cross 2 square matrix is written down at random using the numbers 1 and -1. So, only by using these numbers is a 2 cross 2 square matrix written down. What is the probability that the matrix is non-singular? Okay. So, first of all, in how many ways can you form a 2 cross 2 matrix with the entries 1 and -1? In a 2 cross 2 matrix, there are 4 entries that you need. This place can be filled in 2 ways, 1 or -1. This has 2 possibilities, this has 2 possibilities, this has 2 possibilities. So, this can be filled in 2 ways, this work can be done in 2 ways, this work can be done in 2 ways, this 2 ways, this 2 ways. So, all 4 works, that means the filling of all the 4 places can be done in 2 into 2 into 2 into 2, that is 2 to the power 4 ways. This is the total number of ways in which a 2 cross 2 matrix can be formed with the help of the two numbers 1 and -1. Out of all these matrices, which ones are non-singular? Which ones are non-singular? That means the determinant is not equal to 0. It's very simple to understand that if you take -1, -1, 1, 1, if you take say 1, 1, -1, -1, -1, -1, 1, 1, 1, 1, -1, -1, 1, 1, 1, 1, -1, -1, -1, -1, okay, -1, -1, 1, 1, and -1, -1, 1, 1. These are the 8 2 cross 2 square matrices with entries 1 and -1 which are non-singular, and therefore out of the total 2 to the power 4 2 cross 2 matrices with entries 1 and -1, only 8 are those 2 cross 2 matrices with entries 1 and -1 which are non-singular. This number is 16 and your answer is 8 by 16, which is 1 by 2. Clear? And therefore 1 by 2 happens to be the correct option. Moving on to the next question, we have what is the probability for S's to come consecutively in the word Mississippi? Okay. Let us talk about this now. So, Mississippi word, if you can very easily see, has 11 letters, out of which 4 S's are there, 4 I's are there and 2 P's are there. In how many ways can 4 S's come consecutively when you arrange the letters of the word Mississippi? So, total arrangements can be how many? Total number of ways in which all these letters of the word Mississippi can be arranged in 11 places is 11 factorial. Now, there are 4 S's, 4 P's, no, 4 I's and 2 P's. These are the total number of ways in which all the letters of the word Mississippi can be arranged in 11 possible places. Out of this, I am saying S's should come consecutively. So, what I now do is I consider all the 4 S's to be one single word. I consider all the S's, all 4 S's to be one single letter. Now, I am left with how many letters? 1, 2, 3, 4, 5, 6, 7 and all 4 S's are 8. That's one letter. So, there are 8 letters now. Now, there are 8 letters, 4 S's are one letter. This is just one single letter because they always have to go together. Wherever they are going, they are going to go together. Fine. So, all the S's together are combining to becoming one letter single. Beyond that, in these 8 letters, in which one of the letters is all 4 S's, I have 2 P's and 4 I's. Now, I need to arrange these 8 letters in 8 places, right? And I have 2 P's and 4 I's with me. I cannot say now that there are 4 S's because all 4 S's are now one single letter. So, my favorable number of arrangements will be what? Favorable will be 8 factorial because there are 8 letters which I need to arrange in 8 places, but in that there are 2 P's and 4 I's. So, these are the favorable ways and therefore probability becomes what? 8 factorial upon 2 factorial into 4 factorial divided by 11 factorial upon this or multiplied by 4 factorial into 4 factorial into 2 factorial upon 11 factorial. This gets cancelled, this gets cancelled. This is what you're left with and your answer eventually comes out to be 4 by 165. Clear? So, that's how beautifully this question is dealt with. Now, next question says there are 2 non-negative integers x and y which are chosen at random with replacement, the probability that x square plus y square is divisible by 10. So when x and y are chosen, x, when you divide by 10, you get 10x1 plus a1. This is the quotient, this is the remainder. What is the status of the remainder? A1 is greater than or equal to 0 and strictly less than 10, which is the divisor, or less than equal to 9. I can say anything you can say. Similarly, y, when you divide by 10, you get a quotient and you get a remainder, where the remainder is greater than or equal to 0 and strictly less than 10 or less than or equal to 9. So when I talk about x square plus y square, it is actually 10x1 plus a1 square plus 10y1 plus b1 square. Right? This becomes 10 square into x1 square plus 10 square into y1 square. So 10 square comes out common, x1 square plus y1 square plus a1 square plus b1 square plus 2 into 10x1 into a1, so 20 into x1 a1, and from here 20 into y1 b1, so 20 into x1 a1 plus y1 b1. Now understand, I am wanting x square plus y square to be divisible by 10. X square plus y square is this. This term is divisible by 10. It's 20 times something or 10 into 2 times something. This term is divisible by 10. Only if this term will be divisible by 10 will x square plus y square be divisible by 10, right? So, what is the probability that a1 square plus b1 square is divisible by 10? Then I can talk about that probability being the same probability of x square plus y square being divisible by 10. So now the motive has changed, now our motive has shifted to what is the probability that a1 square plus b1 square is divisible by 10. Now understand, a1 has 10 options. B1 has again 10 options. So A1 square plus B1 square can be written in how many ways? Total number of ways in which A1 square plus B1 square can be written is 10 into 10, that is 100 ways. Out of those 100 ways of A1 square plus B1 square, what are the possible values of A1 and B1 for which A1 square plus B1 square is actually divisible by 10? Those are my favorable ones. See, A1 can take value from 0 to 9, B1 can take value from 0 to 9. So, A1 square and B1 square, both of them can take 100. Both these can be filled in 100 ways. So, A1 square plus B1 square can be formed in 100 ways. Out of those 100, which are the favorable? 0, 0, 1, 3, 1, 7, 2, 4, 2, 6, 3, 1, 3, 9, 4, 2, 4, 8, 5, 5, 6, 8, 7, 1, 7, 9, 8, 4, 8, 6, 9, 3 and 9, 7. Why? Because for example, if A1 is 1 and B1 is 3, then A1 square plus B1 square is what? 1 plus 9, that is 10 divisible by 10. If A1 is 1, B1 is 7. 7 into 7 or 7 square is 49. 49 plus 1 is 50 divisible by 10. So these are all the possible values of A1 and B1 ranging from 0 to 9 such that A1 square plus B1 square is divisible by 10. So out of the 100 values of A1 square plus B1 square, these are the values which are how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Right? So how many you have? 0, 0, 1, 3, 1, 7, 2, 4, 2, 6, 3, 1, 3, 9, 4, 2, 4, 8, 5, 5, 6, 8, 7, 1, 7, 9, 8, 4, 8, 6, 9, 3, 9, 7. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. These are all the ways in which you can basically write A1 square plus B1 square being divisible by what? 10. Clear? So therefore your probability becomes the total number of favorable events upon total number of elementary events, and that is going to give you the answer. So quickly note this down, understand this concept, and we are going to go ahead with the next question.